All right, so we are on Journal 2, and here is the bell work. So this bell work here, we are actually just going over some definitions you might have heard in geometry. So in geometry, you've talked about these different types of angles that happen when you take two parallel lines like these and have a line that goes through them and creates these angles. Now this line here that goes through the two parallel lines is what we call the transversal line. Now you don't really need to know that that this is a transversal line, but I thought I'd let you know. So let's talk about alternate interior angles. So alternate interior angles are basically, when you hear the interior, we're going to be talking about in between those parallel lines, and because it says alternate, it's the crisscross angles. So 3 and 6 are alternate interior angles. So I'm going to write that down, 3 and 6, as well as 4 and 5 are alternate interior angles. And what they mean is that whenever you have an alternate interior angle, the angles equal to each other. And then alternate exterior angles are not the middle of the parallel, they're actually the outside of them. So the 1 and 2 and the 7 and 8. So because they alternate, it's going to be 1 and 8. So we're going to write down 1 and 8 are alternate interior angles, and 2 and 7. And these angles are also going to equal each other. So notice how 8 and 1 are both looking like obtuse angles, whereas 2 and 7 both look like acute angles, because they're the same type of pairing. And then for corresponding interior angles, again, that's looking in the interior here. So corresponding would mean like the 4 and the 6 are corresponding interior angles. So 4 and 6 are a pair, as well as 3 and 5. Now, the thing about corresponding interior angles is that when you add them up, like 4 and 6, you should have the sum of 180. In other words, corresponding interior angles are supplementary to each other. Notice how the 4 here is an obtuse. If you add that with an acute like 6, you get your supplementary angle, your 180. Now let's head into corresponding angle. So corresponding angles also equal each other, and they are located such as 2 and 6. 2 and 6 are corresponding angles. So what I like to think about it is like you have an angle, you skip one, and then you go to the other one. That's how I see the pattern. So I'm going to write down 2 and 6. And then another corresponding angle would be 4, skip, 8. So 4 and 8 are corresponding angles. And then if you go to the other side, well, 1 and 5 are corresponding angles. They're the same types of angles. And then 3 and 7 are corresponding as well. So this table here can feel like a lot to remember. So I want to teach you a trick on how you can remember which angles are equal each other and which one adds up to be 180. So there's a trick called the circle and square pattern, something you can say like that. But it's basically using some symbols here. So you start off at one of the ends. I'm actually going to start at I'll just start down here, 7. And you start with a shape. So I'm going to start with a square, and then it's going to be a circle, and then you alternate by the shape. So this is going to be a square, circle on the 5, square now on the 3, circle on the 1. So notice how I alternated between the shapes, square, circle, square, circle. And then when I head to this side, the 2 needs to also alternate. So if this is a circle, this here needs to be a square. So I have a square, circle, square, circle. And so when I look at this, you will notice that all the circles equals the circles. So notice how the 1 and the 4, they're both obtuse. They are going to equal each other. The 4 and the 8 are also both obtuse. They are equal to each other. And so is like that 5 and that 1. They are the same types of angles. So when you do this pattern and you alternate it by shape, you will notice that it helps you like basically seek out which ones are the ones that are equal to each other, which ones are the ones that, well, actually, let me finish this. So all the circles equal each other. And if you look at the squares, all the squares will equal the same angle. Like that square there is a 3. That square there is a 7. Notice how they're both acute angles. And if you look at the other squares, like this square here and the 3, they're both acute angles. They're going to be equal to each other. And so notice how all the squares equal each other. And then if you have a square and a circle, if you're comparing a square and a circle, it will always add up to be 180. So for instance, like what we just learned a moment ago, corresponding interior angles, notice how the 4 and the 6 are different shapes. One's a circle, one's a square. Well, if you add them together, you get 180 because that's an obtuse, that's an acute. Add them together, you get 180. So that's one way you can figure out which ones are the two angles that when you add them up or pair them up are the same, or when you pair them up equals 180. That allows you not to, remember definitions, just use this trick. All right, let's go into the next slide here. We're going to do some homework problems from chapter 14.2. Now, I'd just like to mention here, in this chapter, or this journal entry, we're going to be going over topics you're going to see in chapter 14.2. So when you are doing homework, I would suggest you do problems from 14.2, problems 3 to 14, and 43 to 68. Don't feel like you need to do all the problems, but those are the recommended problems to do. Okay, so now let's take a look at our situation here. So for number 4 in the homework, notice how we have these two angles, and we have to find what are the actual numerical value for the angle. It's written as an algebraic expression, but we have to find the actual value. So I want to know these two angles. Well, we learned that when they are vertical from each other, they are also the same or equal, or the same angle, or their angles equal each other. So same angle. So what I can do, because they're algebraic expressions, is just set them equal to each other, right? Because then I can at least solve for x. So I'm going to take those two angles, algebraic expression, and put an equal sign between them so I can solve for x. So I'm going to start there. I'm going to add the 37 to that side. Maybe subtract the 7 to that side. This would cancel out, this would cancel out. So 27 plus 37, that's going to give me 64. And then if I do 11 minus 7, that is going to give me 4x. Then I would need to divide 4 to both sides. So x is equal to, okay, let's see what 64 divided by 4 is. It's 16. So now I have x, but hold up, I'm not done, right? It's not asking for me for x. It's asking what is that angle there. So I got to take this x value, plug it back in, get the actual angle here. Same thing for this guy. Plug it in, get the actual angle from here. So I'm going to do that on this side here. So 11 times 16 minus 37. If you plug that into a calculator, you would get 139 degrees. Now, you can also just, you could plug in 16 into that x, multiply by 7 to find this guy here. And you realize you also get 39. So if you don't want to do the second one, just because you know that these are vertical angles from each other, don't feel like you need to find the other angle because you know they're going to end up equaling each other. So in this case, this is our answer. Let me grab my highlighter here. So I know that this angle is 139 degrees. This angle is also 139 degrees. All right, so the next one here, we're not dealing with lines anymore, is we have a triangle. So just keep in mind, whenever we have a triangle, the sum of the angles for the triangle, so sum of angles for triangle will always be 180 degrees. So that means if I were to add up all these angles here, I should get 180 degrees. However, again, they are algebraic expression. I will need to find the actual numerical value. So what I have to do is actually take each algebraic expression and add or combine them all and set it equal to 180. So I'm going to go ahead and do that here. So I'd have x plus 15. I would have 10x minus 20. Add that with x plus 5 equals 180. And so now I get to solve. So let's see if we can combine any like terms here, like the x, 10x, x. If I combine those two, I get 12. And then if I combine the numbers, 15 added with negative 20 added with 5 gives me 0. Cancels out basically. And so this equals 180 on this side. If I divide by 12, x is equal to 15. And so now I have my x, but I'm not done. Remember, we are not looking for x, we're looking for the angle. So I have to plug this x back in to my angle here. So 15 plus 15 gives me 30, but I'll write it out here. 15 plus 15 equals 30 degrees. The other one here, 10 times 15 minus 20. So 10 times 15 minus 20 is going to equal 130 degrees. And then last but not least, the other one, x plus 5, is going to be 15 plus 5, which is equal to 20 degrees. You'll notice that when you add up these degrees, you should get 180, and we do. So, like I said, this one was 30 degrees, this one was 130, and this one was 20 degrees. And there we have it. All right, let's try some other problems similar to this. Okay, so in this problem here, number 10, it's a little bit tougher. Okay, I am going to say that. So this problem wants you to figure out what is these angles here. The only thing is that we could figure this out easily if we just knew what this angle was. But we don't, and that's the issue. And a lot of people are going to assume that this angle is the same as this angle, but it's not. Notice, I mean, you can already tell by the picture that this one is a little bit steeper than this one here. So what we have to do is understand that this is in two pieces here. One, I can see the triangle. So I need to find that angle that's right there. Or at least I know that there's an angle that I haven't have any symbols that represent. But then we also realize that this is on a straight line, right? It's on a straight line, which also adds up to be 180. So that means that if you wanted to figure out this angle here, you would take 180 subtracted by 712x. So this also correlates back on how you can find the angle here. So what you can do here is make an equation that allows you to find this angle, because that would allow you to set them equal to each other, because you know you're going to get the same angle. So here's what I mean. Let's focus in on the triangle first. So I know that this triangle has to be equal to 180 degrees, right? Yeah, so because it's a triangle, all the angles have to add up to be 180. So if I wanted to find this angle here, I would just take 180, subtract it, this from 180, and also this from 180, and whatever's left over goes here. So what that might look like is 180 minus negative 8x plus 3 minus 5x. And then the other one is going to be, oh, I think I forgot about minus sign. There should be a minus sign. Let me erase that and I'll just start over. There we go. And so for the other straight line, we can say that this line, or this angle here, is 180 minus this angle here to give you what's left over. So we would have 180 minus 7 minus 12x. Now you might have been noticing that I kept those parentheses there when I'm subtracting it off, and that's because I have to distribute that negative sign into my parentheses. If I didn't do that, that would cause weird and strange things to happen. Your answer might not come out right. So what I'm going to do next is just simplify like we usually do, like distribute this negative sign. So I would have 180 plus 8x minus 3 plus 5x. And then on this side here, I would have 180 minus 7 plus 12x. And so now when I look at things here, if I combine like terms, I would have 180 minus 3, which is 177, plus 8x plus 5x, which is going to be 13x, equals 180 minus 7, which is 173, plus 12x. So from here, if I want to get x by itself, I'm going to need to get x on one side on its own. So I'm going to remove the maybe 173. And so that leaves me with 173 is 4. And then if I subtracted 13x to both sides, 4 would equal negative 12x minus 13 would give me just a negative 1. And then if I divide it by a negative 1, x is equal to negative 1, because 4 divided by negative 1 is just negative 1. All right, I'm not done yet, unfortunately. Sorry about this. I have to plug this number into the each algebraic expression to find that angle. So when I do that, I plug in negative 4 into this here. I'll write it to the side, so negative 8 times negative 4 plus 3. I get, let me grab my calculator here. I get 35 degrees. When I plug things into the negative 5x, I get 20 degrees. And then last but not least, if I take 7 minus 12, put in negative 4, I get 55. And so in this case, this is my starting point. And yeah, that's it for that problem there. We have a few more slides to go, but that was the hardest slide, I would say. Oh, I guess I forgot about 13. Let's do 13 together. So I'm going to just write the answers here for that last problem we did. So this one here was 35. Oops, that's a highlighter. Okay, so from here I'm going to erase this so I can do the other problem. So take a look at the problem that we have in 13. All right, so for 13 here, notice how these two angles are on the same side, and they almost look like, one looks like an acute and the other looks like an obtuse. So I feel like when we add them together, we're going to get, we're going to get 180 when we add them together. But if you're not sure, remember, you can use that pattern trick where you determine what type of angles they are. So remember, you start out with the shape, and then you alternate. And so I could have done more. I could have like this been squared, 0, squared, 0. But I really just could have stopped right there. So notice how this one is a circle, this one's a square. So that means when I add these together or compare these two angles, I should get 180. And so that's been confirmed. And so I'm going to take this, these algebraic expressions, add them together, and then set them equal to 180. So when I add them together, I get, let's see, x and x can be put together. So that gives me 5x, and then the 1 and the negative 56 gives me negative 55, which equals 180. If I add maybe 55 to both sides, this cancels, and so 5x is equal to 135. And then when I divide by 5, x is equal to 40. Oh wait, hang on, I did not do that right. Shouldn't be 135, should be 235. My bad. 235, and so when x is divided by 5, so 235 divided by 5 gives you 47. And so now we would just plug these number in. And so if you plug 47 into x plus 1, you get, I'll kind of just write the answer here. You can obviously, work it out. So this would give you 48 degrees. And then this one here, if you were to do 4 times 47 minus 56, you are going to get 132 degrees. Okay, so that's it on the measuring the angles. Let's take a look at some other problems here. Alright, so let's talk about finding angles in similar triangles. So similar triangles, just talking about triangles that have the same angle in the same position. We're talking about when we're comparing two triangles here. Like notice how this angle here is 46, and those double curves there are just saying that this M here is also 46 degrees. Same thing with the C angle here, 78. Which is correlated to P. These two are the same angle, so this guy is also 78 degrees. So B and M all equal 46. I'll write that down. and then C equals P, and they equal 78. And then we need to find out what the other angle is. Well, easy enough. We just have to take 180 and subtract it from 46 and 78. So if I were to do that, I would get 56 degrees. So that means my A and my N is equal to 56 degrees. Okay, so easy enough, right? Let's do one more together. So this one here, there are these box angles. Remember, those are just 90-degree angles. Ooh, I've got my highlighter on. 90 degrees angles. And so I have another 90-degree angle here, it looks like. And so they also said that this Z is a 38 degrees and P is 38 degrees. So now we just have to find the X and the M angle, which are going to be similar to each other. So in this case, let's just go ahead and label what we already know, which is that Z and P are equal to 38 degrees, and then Y and M is equal to 90 degrees. And then if we take 180 and subtract it from 90 and 38, we are going to get 52. So it looks like X is equal to 52 degrees. And so in this case, 52 degrees is going to be right here. Actually, let me fix this so I can add more in. So that'll be X M equals 52 degrees. All right, so now we're going to take a look at similar lengths in triangles now that we've talked about angles. All right, so now let's talk about similar triangles and when we're trying to find the lengths of the similar triangles. So these two triangles here are similar. Notice how these two angles line up. I need to get my marker. There we go. So these two angles align, whereas these two angles align. So what we can do is take one of the, or two, make sure that you have the length that matches. So this length, seeing that the angle's here, matches up with this length here. So the 75 and the 25 are similar to each other, okay? Whereas the A is correlated to the 10, the B is correlated to the 20. So what you need to do is, let's say we're finding A. So we're finding A. We can create a proportion whenever we have similar triangles to figure out what the missing length is. So if we have a side to the triangle like 75, and we set that equal to the proportion that is on the triangle where we have all the values. So this 75 is correlated to the 25 side, so I'll make sure I put that in the denominator. And then the A is correlated to the 10, so I need to make sure that that's in the numerator. Then from there, I'm going to try to solve for A. Now, if you remember, when you have like fractions that look like this, you can solve them by multiplying it diagonally, like this. So if you multiply diagonally, 75 times 10 gives you 7,500 equals 25 times A. And if you divide that 25 over to both sides, that means A is equal to 30 is your length here. Now we're just going to find the other side and do the same thing. So this time around, I want to find B, and And I have one of the sides, which is 75. 75 matches up with the other triangle, which is 25. But the B on this triangle matches up with the 20, so I need to make sure 20 is on the top. And so then again, I would multiply diagonally to try to solve for B. So this would be B 25. Let me write it, 25 in front. And then the other side would be 75 times 20 gives me 1,500. And so now I divide the 25 over to both sides. B is equal to 60. And so there we have it. We have our lengths of all sides of this triangle. So this side is a length of 30 and this side is a length of 60. We can do that again here if I want to find this M here. So remember, you want to match up your what you're trying to find. So if I'm trying to find M here, I'm trying to find, so notice how your 12 and your M are on the same side of the similar triangles. So I'm going to make 12 and M on the same fractions. I just put M in the denominator, but it could have been in the numerator, that's fine. But when I create my other fraction, if the numerator here is 12 from this triangle, that means I need to use the 14 for this one. And similar to this side here, this triangle side would be the 21. And then I would try to solve for my M. Multiply diagonally, so that's going to be 14. 12 times 21 is going to give me 252. Divide by 14. And M is equal to 18. And so M needed to be a length of 18. All right, let's do one more of these, or two more examples of these types of triangles, and then we are done for this journal. All right, so this one here, I have this triangle, this big triangle here, but notice inside the triangle you have another teeny tiny triangle. So when you create a triangle that's inside of another triangle, what you do is you create actually similar triangles. So notice how these angles are the same. These angles are also going to be same because it's still inside this triangle. So what you can do is you're going to have to find that variable. So this variable here is y. So how I can do that is by creating that proportion again. So remember, if I want to find y, I have to find that corresponding number that's on the other triangle. So if this is y here, then this is the length of the corresponding side for the bigger triangle. So I'm going to put that on the same fraction. Now remember that your numbers have to match from the same triangle. So if this y is here, I could use this length, the 40, and I'm going to put that in the numerator, because these two values come from the same triangle. Notice this comes from the small piece. Now this one here has to come from the big triangle. Now because I use this 40, which is the base of this tiny triangle, I need to use the big base, or the base of the big triangle. So that's 160 plus this little side here, so 160 plus 40 is actually 200. And now I can solve for my y. So I would multiply that diagonally, like we did before. So y times 200 is 200y. 40 times 60 gives you 2,400, and then you would divide by 200. So y is equal to 12, and you have the length of that side. So if this length is 60, that length had to have been 12. And let's do that again here. So I need to find m in this length. So I'm going to, try to solve for m, start my fraction. Now, in this case, that's going to be correlated to the side. That is, so if this is m, that means that this is the bigger triangle. And the smaller triangle is going to be the 80. So it looks like your hypotenuse almost in a way. So that's 80. Now remember, if this triangle here, or this side here, the M comes from the big triangle, can use maybe the length of maybe the base. So 5 plus 75 is going to give me the base of the big triangle, which is 80, over the base of the small triangle, which is 75. So notice how the base of the small triangle is your 75 value. And then you would try to solve. So M times 75, 80 times 80. You're going to get 1600 on this side. 75 times M, divide 75 to both sides. And M is equal to 85.33 is your length here. And that's it. So now I know the side of this length. All right, that's 10 problems for you guys straight from that homework. Remember, problems from chapter 14.2, and these problems are 3 to 14. And let me just double check here so I have those numbers correct. So you want to do 3 to 14 and 43 to 68. Try out those rest of those problems for extra practice, but here are 10 of them for you. I also want to mention, you want to keep notes in your journal, or kind of keep them with you, because when we do our homework check, or is that quiz that we're going to do later, remember, you can use your notes for that homework check quiz. So that homework check quiz is an open book quiz where you can bring your notes, the homework that you do on the side, and so bring that, and that might help you when you are answering the questions on that homework check quiz. All right, that's it for today, guys. Have a great day.